Hey there, fellow makers and aspiring roboticists. Have you ever looked at a complex robot and wondered, how can I build something like that? The answer, my friends, lies in the incredible world of Arduino. This tiny but mighty microcontroller is the beating heart of countless DIY projects, from simple LED displays to sophisticated robots capable of navigating mazes and interacting with their environment. What makes Arduino so special? Imagine a brain that you can program to control motors, read sensors, and make decisions based on real-time data. That's Arduino in a nutshell. Its simplicity, affordability, and vast online community make it the perfect platform for anyone looking to dive into the exciting world of robotics. But enough talk, let's get our hands dirty. In this step-by-step guide, we'll explore how to connect essential components like servo motors, brushless motors with ESCs, and a FlySky FS-i6 transmitter and receiver to an Arduino board. Along the way, we'll learn about the MPU6050 sensor, a powerful tool for sensing motion and orientation. Get ready to embark on an electrifying journey into the heart of robotics. Before we dive into the nitty-gritty of wiring and coding, let's gather our tools and components. Think of this as assembling the ultimate robotics starter kit, your arsenal for conquering the world of DIY electronics. First and foremost, you'll need an Arduino board. The Arduino Uno is an excellent choice for beginners, offering a balance of simplicity and functionality. Next up, we have the MPU6050 sensor, a tiny chip that can detect even the slightest movements and changes in orientation. This sensor will be our robot's eyes, allowing it to perceive its surroundings. To bring our creation to life, we'll need some muscle. Servo motors are perfect for precise, controlled movements, while brushless motors offer raw power for high-speed applications. Don't forget the ESCs, or electronic speed controllers, for regulating the power flowing to your brushless motors. Finally, we'll be using the FlySky FS-i6 transmitter and receiver to wirelessly control our robot, giving us the freedom to command our creation from afar. Of course, no robotics project is complete without a breadboard, jumper wires, and a USB cable to connect our Arduino to the computer. With these essential components in hand, we're ready to embark on our robotics adventure. Time to wire up the brains of our operation. The MPU6050 sensor will provide valuable data about our robot's movements and orientation, allowing us to program intelligent responses and behaviors. Don't worry, connecting this little chip is a breeze. First, locate the VCC pin on your MPU6050 sensor. This pin needs a steady supply of 5 volts, which we can conveniently source from the 5-volt pin on our Arduino Uno. Connect these 2 pins using a jumper wire. Next, connect the GND pin of the MPU6050 to the GND pin on the Arduino, establishing a common ground reference. Now for the data lines. Connect the SCL pin of the MPU6050 to the SCL pin on the Arduino. On most Arduino Uno boards, the SCL pin is also known as Analog Input 5. Finally, connect the SDA pin of the MPU6050 to the SDA pin on the Arduino, which is also known as Analog Input 4. With these 4 connections in place, our MPU6050 sensor is ready to start feeding valuable data to our Arduino brain. In this segment, we'll visually demonstrate how to connect the components we've discussed. Watch closely as we connect the Arduino board, MPU6050 sensor, servo motors, and the FlySky FS-i6 transmitter and receiver. This visual guide will help you understand the wiring and connections more clearly, ensuring you can replicate the setup with ease. First, let's start with the Arduino board and the MPU6050 sensor. As we mentioned earlier, connect the VCC pin of the MPU6050 to the 5-volt pin on the Arduino. Then connect the GND pin of the MPU6050 to the GND pin on the Arduino. Next, connect the SCL pin of the sensor to the SCL pin on the Arduino, and the SDA pin to the SDA pin on the Arduino. Now, moving on to the servo motors. Connect the power wire of each servo motor to a 5-volt power source. Attach the ground wire of each servo to the ground rail on your breadboard. The signal wire of the first servo motor should go to digital pin 2 on the Arduino, the second servo's signal wire to pin 3, the third to pin 4, and the fourth to pin 5. Finally, let's add the FlySky FS-i6 transmitter and receiver to our setup. Connect the receiver's power wire to the 5-volt pin on the Arduino, and the ground wire to the ground pin. Then, connect the signal wire of the receiver to one of the digital pins on the Arduino, such as pin 6. By following these visual steps, you should now have a clear understanding of how to connect all these components together. Stay tuned as we move on to integrating servo motors with our Arduino in the next scene. Now that our Arduino can sense its surroundings, let's give it some muscles to move. Servo motors are ideal for precise and controlled movements, making them perfect for applications like robotic arms, grippers, and even animatronic characters. Each servo motor has 3 wires: power, usually red, ground, usually black or brown, and signal, usually orange or yellow. Connect the power wire of each servo motor to a 5-volt power source. Similarly, connect the ground wire of each servo to the ground rail on your breadboard. The signal wire is where the magic happens. Connect the signal wire of the first servo motor to digital pin 2 on your Arduino Uno. Connect the signal wire of the second servo to digital pin 3, the third servo to pin 4, and the fourth servo to pin 5. This configuration allows us to individually control each servo motor using simple Arduino code.